Good morning, everyone. My name is Nikta Sarkar, and I am the CFD Application Engineer here at KETIV. I welcome all of you to today's Ansys Virtual Academy session. I haven't done these in a while because we alternate between CFD, structures, and electrical electronics. But the topic that I will be discussing today is common to all different branches of simulation. And it's very important, especially from a pre-processing point of view. A lot of our customers reach out to us and ask us about the steps involved in connecting their native CAD platforms to the Ansys workbench. And so this AVA will focus on using Ansys SpaceClaim and Discovery for parametric CAD modeling. I will start the presentation with a small discussion talking about the differences between parametric modeling and direct modeling. And then we will cover the topics related to setting up parameters in SpaceClaim in the conventional way, some of which you may already be familiar with. And then I will touch upon importing the CAD parameters from your native CAD platform into SpaceClaim. And then lastly, move on to Discovery. Feel free to leave your questions in the Q&A box that you see on your screen. I will be able to take the questions towards the end of the session. And if there is any question that I'm not able to answer on the spot, we can always get back to you. All right, so with that, let us go ahead and get started. Now, a lot of the Ansys users know SpaceClaim to be a direct modeler. Quite literally, it was called SpaceClaim Direct Modeler, right? And oftentimes we get questions around how is direct modeling different from other traditional CAD platforms, and why can't we see the feature tree or the history tree in SpaceClaim? So this AVA is intended to sort of go over the comparison between parametric modeling and direct modeling and how you can use SpaceClaim for both those functionalities. Now, on the left, you see the features associated with parametric modeling. Typically, it is also known as feature-based tracking or history tree tracking sort of modeling. This is very familiar to you if you use, say, for example, Design Modeler for pre-processing your geometry before a simulation today, or whichever native CAD platform that you might be using. Say, for example, on my computer, I use the Autodesk Inventor Pro 2021. You have a feature tree where each and every step gets recorded. There are relationships, there are constraints between different dimensions in your geometry. And these constraints, these relationships drive how you are going to create your geometry. So in a way, you need to know, okay, what does my final product look like? And what are the constraints that need to be put into place in order to get the final product? The good thing about parametric modeling or a feature-based or history tree-based modeling is that because the intermediate steps are recorded, say, for example, over here, you can see whichever steps you perform to create the final geometry, they're already there in the tree. You can go back to any particular step and then perhaps change a dimension, change a value, and then go down the list again. Now, this functionality is not available with direct modeling because direct modeling gives you the advantage of making fast modifications to your geometry without being constrained or bogged down by previous relationships that may exist in your history tree. So a few releases ago, SpaceClaim used to be a direct modeler, meaning that you could almost treat your geometry like virtual Play-Doh. Whatever final product that you would see on your screen at that moment would be your starting point for all future modifications. So you would not be able to keep a track of all the steps that you performed in order to get the final geometry, which both has pros and cons. Pros meaning that you can quickly edit your geometry without being tied to your previous constraints. The con, however, is that if you wanted to go back to a previous step and change something, then you would have to start over again. Now, what if we could combine the best of these both worlds and use both those approaches for cleaning up your geometry before you set up a simulation? SpaceClaim and Discovery within the Ansys framework give you both these options. And to all those users, all those customers who've asked me, hey, will SpaceClaim or Discovery be able to handle our feature tree? Yes, the answer is SpaceClaim can handle both. And in this AVA, I will go over, how to make sure that you're setting up parameters, you're recording the steps, and you're able to import parameters from your native CAD platform so that they can be tracked down that history tree, down that feature list, and updated at will. So with that, I'm just going to directly jump into the demonstration part so that I can show you how it is done. And then later on, we will come back to this presentation. So let me go ahead and share my workbench with you. I am using Ansys Workbench 2021, and I'm going to go ahead and open SpaceClaim. Please let me know in the chat window if you're not able to see my workbench screen and if I'm still sharing my presentation, but I think I'm sharing my monitor, so you should be able to see workbench. All right, so I have a blank slate here. And before we dive into the interoperability between having a direct modeler and a feature tree based modeler, let me first talk about how to set up parameters in SpaceClaim in general. I think a lot of the users are already familiar with some of the conventional ways, but for those of you who have not used SpaceClaim for parametric analysis or for setting up design studies in Workbench, maybe this would be good information that will help you follow through for the rest of the AVA. So I have a blank slate here. I'm just going to, create a random geometry, nothing too complex. Let me just go ahead and create a rectangle, maybe a circle in between. Maybe I'm just going to go ahead and pull this guy to create a solid object. And then let me go ahead and delete this surface over here. So if you look at the structure tree, you have a solid over here. And this is a very good example of direct modeling because you have your final structure over here, but you didn't have any of these steps that I performed, which included sketching and extrusion recorded anywhere. So if I wanted to go back and change anything, I can't do that, but I do have a very fast, very easily modified geometry in front of me. Now, what are some of the traditional ways of creating parameters in SpaceClaim? Well, first of all, I'll talk about the pull tool over here, right? Anytime you want to move a face, or anytime you want to extrude a face, rather, you can select any one particular surface and then just go ahead. Excuse me. Sorry about that. So you can use the pull functionality, select a surface, and then pull it from a reference point. Now, when you select a surface, and if you don't use your mouse to immediately pull it, you will notice some options that show up over here. One of the options is the ruler function. This option is also available to you if you go to the options tab over here and then select this, right? So let me go ahead and select this ruler guy over here. And what it basically asks me to do is select a reference point from which that ruler dimension is being measured. Whenever you're creating parameters, keep in mind that that distance is being measured from one reference location. If SpaceClaim does not know that reference location, you would not be able to create that parameter. And this is, again, one of the common queries that we face, when we're dealing with support requests, is like, hey, I clicked on pull, but I didn't see the option to create a parameter. That's because you're not selecting a reference location from which that distance is being measured. Because remember, parameters are driving dimensions. They're driving your design, So they need to be accounted for from one particular reference location. So in this case, what you see on your screen is that the distance is being measured from the center of this circular feature. You can see the reference location by this yellow dot over here, right? Once you select a reference location, you will see the option of, selecting P. So say, for example, I go ahead and select this reference location. I can click on this P symbol and it'll automatically become a parameter. This parameter will be visible in the groups tab over here, where you'll be able to select the ruler dimension and look at the current value of that dimension. If I wanted to go ahead and change it, I could make it 15 millimeters and it would automatically update. You could go ahead and rename this guy just for your own reference and understanding. But otherwise, these parameters show up in your workbench project. So as soon as you have a parameter in your SpaceClaim file, this parameter set will be activated within Workbench, which will have these geometric parameters available to you. Now, this was one way of creating a parameter. What else can we do? We can select any circular feature, a circular face, for example, and it'll automatically give us an option of selecting the radius of that circular feature to be a parameter. It is obviously calculating that distance from the center of that circular feature. So again, I can go ahead and add this as a parameter, and it gets added in this groups list over here. Another thing that you can do with the pull functionality is add rounds. So anytime you go ahead and select an edge, right, and you pull this guy, there is a radius that is being associated with the round that you just created. That radius again can be defined as a parameter. So let me go ahead and add that to the list as well. You will notice that most of these parameters that we create in SpaceClaim, they're either lengths or they're either radius. There might be some parameters that also refer to the properties of your solid, say, for example, mass. Hopefully, we can cover that later on. Now, this was using the pull feature, right? You could also use the move functionality to do something similar. Say, for example, I want to move the location of this circular extrusion. So I could select this guy and then select the direction in which I want to move it, right? And then select the ruler option. And again, it will ask me what is the reference location from which I'm measuring the distance by which this needs to be moved. Say, for example, I select this face over here. I can again set this as a parameter. So if, for example, I go ahead and change this to 12 millimeters, so you'll see that the circle automatically moves, right? So this is another way of, assigning a parameter. Now, another thing that you can do is, say, for example, you are looking to make some measurements in your domain. So say, for example, I want to pull this guy, right? And I go to options and I select this symbol here for measurement. I can select this surface and then select another surface and then measure between these two surfaces to select the dimension or the measurement between these two locations as a parameter as well. In order to do this, you need to make sure that you select the surface first. If you simply go ahead and if you simply are in the pull functionality and select these two surfaces, you may not be able to measure the distance between them and set it as a parameter. But if you select the surface first, right, select it, then go to options, then choose measurement, then select the surface again, select another reference surface, and then try to change it or set it as a parameter if you need to. So I could go ahead and set this as 30 and then also add this as a parameter. It again gets added to the list over here. All right. Another thing that you can do with the pull functionality is use the draft feature. So say, for example, I'm using the pull functionality to say, look at this surface, and then I select the draft option over here. It'll ask me to select a reference plane about which I want to draft this surface. So let me go ahead and select this guy over here. And I could change this angle, right? I could make this 5 degrees, right? And it'll automatically increase the angle between these two surfaces over here. So you could go to groups again. And do you see that this create parameter option is available to us? So we can simply select it, and this 5 degree can get added as another parameter that you may want to vary in your problem. Okay, so these were some of the ways in which you could go ahead and set up ruler dimensions or driving dimensions, including length and radius and angles. But what about mass properties? So say, for example, I select a surface over here, and then I come to the options panel, and instead of selecting the measurement, I select mass properties over here. When you select mass properties, you are able to look at the properties for that entire solid. Now, if you don't have a material assigned at this point, you will only be able to see the volume, but you could go to properties over here and then select any material that is available to you. Say I select aluminum, and once it has the density based on the volume, it can automatically create the mass. But here, this mass can be parametrized depending on that first surface I selected. Remember, I had selected this surface and then clicked on this guy. So because this surface was selected, what it is asking me to do is parameterize the mass in general, and then it'll vary the dimension of the selected feature based on the intended mass outcome. So from 25 gram, if I want it to be 28 gram, it'll automatically change that surface to account for the extra mass that we are putting in the solid structure. Now, this sort of functionality can be important for those people who are looking to target a certain mass depending on the material that they use for their design. And having these, goal-oriented modifications that you can make to your geometry may come in very handy. Okay. So these were some of the common conventional ways of, setting up parameters in your domain. And maybe you guys are already familiar with this, but for those of you who have not used parameters that often, I hope that was beneficial. Now, this is all associated with direct modeling. We still don't see a feature tree. We still don't see history tracking over here. So what SpaceClaim has done now is that it always had this Python scripting capability, which basically allowed you to, customize your steps and keep a record of it as you keep modifying your geometry. But a better skin that has been applied in SpaceClaim recently is something called block recording. So it's under the design tab over here. If I select it, you will see that there's a separate panel that shows up on the right over here. And what this block recording does is it allows you to track all the steps that you perform in your simulation this point onwards. So say, for example, I go ahead and pull this face even further. You will notice that as soon as I did that, there was another block of code that showed up in this panel over here, which is called extrude face. So this is basically recording the step that you just performed. If I click on this arrow over here, it gives you a little bit more detail into what happened. You could look at the selection over here, or the distance by which this face was pulled or offset, or whatever modification you made. Now, if you wanted to add the dimension by which you offset the face as a parameter, you could simply go and click this guy over here. And what it would do is it would add that distance or that measurement in the parameters panel, which then get added to Workbench. You could also go ahead and simply change the value over here. So say, for example, I go ahead and pull another guy over here, but this time I don't want it to be a parameter. I just want to change the value. I could simply go ahead and click this green arrow on the top so that I am able to run this block of code, and it'll automatically adjust and modify my geometry accordingly. Okay. And one extra thing that you may note is that as soon as I add a distance as a parameter, the value shows up over here, but it basically gets assigned a variable. So say, for example, if you were using a Python code instead of, using this more user-friendly skin, then you would basically be assigning a variable that can be later on modified depending on the steps that you wanted to change. Okay. Now, say, for example, I go ahead and change this value. Okay. As soon as I change this value over here, this value that was defined in the very first step, all the following successive blocks of code under block recording show this flash symbol over here. This means that the successive blocks of code need to be updated in order for you to get the final geometry. So you could simply go ahead and run them, and then accordingly, everything will be updated. So this is a really convenient feature, because now you can first of all keep a record of all the steps that you followed to get your final geometry. And if you want to go back to the first step and change a dimension, all you need to do is either change it here or change it here, and then click the green arrow, and all the successive steps will automatically be regenerated. So it reduces the repeatability, or the manual effort that goes into preparing your final geometry for setting up, say, a CFD simulation or a structure simulation or an electrical electronic simulation. The only thing is, the caveat with all feature-based trees is sometimes based on the constraints or relationships in your domain. There might be cases in which, say, for example, if you wanted to move this, like, if you wanted to move this, you could, but there might be a case in your geometry wherein, parameters in different blocks sort of interfere with each other or contradict each other. And in that case, there might be an error saying that, oh, maybe this particular block was not executed, and you would have to come back and then see, okay, what went wrong, or, what is conflicting. But for 90% of the cases, if you set up the model correctly, if there are no, conflicting commands in the code that you set up over here, you should be able to update your geometry with a single update in dimensions or values. So the reason I mentioned block recording is because this is the main functionality that allows you to connect your Ansys tools to your native CAD platform. If you did not have this functionality, you would be able to import your geometry, say, from example, Autodesk into Ansys, but there is no way to keep updating the geometry parameters that you imported, because there is no history, there is no tracking. So you would just get the geometry at the very beginning, but you're not tracking any steps. So whatever changes you make in SpaceClaim don't automatically get updated. So let me go ahead and show you how you would connect your native CAD platform to your Ansys tools. I have Inventor open on my end. Let me go ahead and share this on the screen. You may have a different CAD platform on your end. So somebody has asked me, can you please tell the ruler type once again? I will go over it. I will go over it once I get back to SpaceClaim. I will show you again how to use the ruler dimension for setting up a parameter. So I have Autodesk Inventor Professional 2021 on my computer right now, and you may have a different CAD platform. The methodology of importing parameters from your native CAD platform to Ansys is similar. How you set up the parameters individually in your own tool may differ. For my example, I'm using Autodesk. Now, before I go into the steps, one prerequisite for you to be able to maintain that active connection between your native CAD tool and Ansys is that you would need a CAD interface license, because that allows you to have a plugin in your native CAD platform. So say, for example, you can see 2021, 2020 R2, 2021 R2 already installed on my Autodesk installment. So how do I add this? You could go to environments and you could select add-ins. And this basically gives you a list of all available licenses. And you will see that the Workbench licenses that I have currently loaded on my computer show up here. I have the load automatically option selected. And so every time I launch Autodesk, these tabs are automatically visible. So I don't have to manually, reload them every time. Okay. So make sure you have that CAD interface so that, you can have that two-way connection between your CAD platform and Ansys. So I have an example geometry over here. Okay, nothing crazy. In fact, this is pretty similar to what I created in SpaceClaim. And I have certain geometric parameters associated with this design that I have. So one is the length of the extrusion. So I just created a sketch plane and then extruded it by some length. So this is basically the length of the geometry. And then I have another dimension for the radius of this circular face over here. So I created that as a second sketch and then assigned it as a parameter over here. The only other thing that you need to do on your end, or rather, inside your CAD platform, is to make sure that you have the prefix DS or ANS next to your parameter names. DS and ANS basically indicate to Ansys that these are the parameters that are meant to be imported into Workbench when you try to transfer your geometry. So if you did not have these prefixes, then Ansys wouldn't know which to import. And you could only choose DS. I just had one DS and one ANS for the sake of example, but you could only use DS or you could only use ANS. Okay. And you also see their values over here. So say, for example, I changed this from 2 inches to 3 inches. This will automatically be updated. Similarly, if I were to change this from 0.3 to 0.4, again, you see that the update is automatic. So then what do I need to do to transfer this to Ansys? Very simple. I just go to Ansys 2021 R2. And let me actually close SpaceClaim so that, I can show you how to launch it from your CAD platform directly. I only have one license, so I don't want the license to be tied up. Okay. So all I do is I go to Ansys 2021 R2, and then I select this Workbench guy, and it'll automatically launch Workbench for me. And we should be able to see this geometry already imported. Okay, so now you see on your screen that because I was working with the Workbench plugin in Autodesk, this geometry shows up as an Inventor geometry over here. I can simply go ahead and double click it. And my default CAD tool is SpaceClaim. You can also choose Discovery if you own that product. And I'll show you how to do that in just a second. So depending on whether you're more comfortable with SpaceClaim or you're more comfortable with Discovery, you could open the imported geometry in either of those tools. Okay, so we have the geometry imported from Autodesk. And before I start talking about it, let me quickly show you how you can choose a different tool for opening your default geometries. You could go to Tools, Options, Geometry Import, and then it says Preferred Geometry Editor. So if you select the drop-down menu, you could choose either Discovery or Design Modeler, whatever you want to choose. But for this AVA, we are specifically talking about SpaceClaim and Discovery. So I'll leave it at SpaceClaim for now and go back to my SpaceClaim model. So since this was automatically imported, one thing that you will immediately notice is that even before I did anything, block recording was already turned on. And the reason why block recording is already turned on is because we are telling Ansys to, connect an active CAD session to SpaceClaim, right? And like I said, the only way those parameters can be updated or be tracked is by having this, history or feature-based tree that can, record the steps for whatever modifications we make to the parameters that we imported. If you look at this block over here and select this option, you will notice the two parameters that had the prefix ANS and DS. So those were the only ones that were imported from a list of 4 parameters. So I could go ahead and check these 2 boxes. And as soon as I check these boxes, they show up at the bottom over here. And they should also be visible in the workbench parameter set. If you didn't select or check those boxes, this space would be empty. And that basically means that workbench is not working with any parameters. Having the parameters in this box gives you the ability to, work with these in, say, for example, a design study problem or a parametric study problem that you set up in Workbench later on. Okay. Some of the import options are automatically visible when you go ahead and select this guy over here. Say, for example, the Smart CAD update or import using instances. But if you wanted to look at the import options in SpaceClaim itself, you could go ahead and select this guy, and it'll give you certain options that you may want to change depending on the import that you do from your native CAD platform. Okay. Now, we have imported the geometry over here. What happens if we change any of these dimensions? Say, for example, I change this length from 3 to 2 over here. I changed it to 2 and I hit enter and I see this flash symbol over here. That means I have to run the code again. And after I run the code, you can see that the length is modified because I changed this value. Now, the big question is, okay, I changed something here, but what is happening in Inventor? What is happening in my native CAD platform? So if you go back to your CAD platform, you'll see that because that active connection was maintained, this geometry is also automatically updated. So you could again go back to your parameter list and see that now the value has changed from 3 to 2. Okay. Similarly, for example, if you want to make a change over here, say I want to make this 0.3 instead of 0.4, immediately you can see that the change is reflected in Inventor. But what about SpaceClaim, right? SpaceClaim is still showing 0.4. Well, all you need to do is right click on this block over here, and there's an option of updating from source CAD. So I'm going to go ahead and select that. And you will see that the whole shrinks in size, and now the new value that is reflected is 0.3. And this is the very purpose of maintaining that active connection between your native CAD platform and your Ansys tools, because if you make a change in, say, Autodesk, you want that to be automatically carried over. If it is not carried over, then you might as well just export an IGS file or a step file and read it in manually. But this makes the process a lot more automated, a lot more efficient. And now whatever modifications that you want to make here to the geometry, you can automatically make, and they will keep getting recorded in your block tree over here. Okay. Okay. Now, here's the thing. What about the bidirectionality of these modifications that we are making? Sure, we changed the value of the dimension or the parameter that we imported from Inventor, and that got carried over. But if we make some other modifications, say, for example, I go ahead and create a round here, will that automatically be reflected in Inventor? No, it won't. Because the inherent kernels of your CAD platforms will be different from the kernel that is being used inside SpaceClaim. So the only link that you have between your native CAD platform and your geometry within SpaceClaim or Discovery are the parameters that you're importing from Autodesk. So if those are the values that you are changing, yes, you will be able to see that effect inside Autodesk. But if you're making other modifications, those are separate parameters only within the realm of SpaceClaim. Those do not get carried over to Inventor. Okay, so that is an important detail to keep in mind, that yes, there is bidirectionality, but it is limited because of the basic difference in the underlying code of two solvers. So it's not easy to just go ahead and make modifications of whatever kind in SpaceClaim or in Discovery and then see that same effect take place in your CAD platform. Okay, now another thing that you may want to see here is, say, for example, I extruded this face by a certain distance, right? I can go ahead and make this a parameter, and now this shows up as a variable name, B2_P1. And then I went ahead and I created a radius for this round over here. Now, if I wanted to maintain some relation between a previous parameter and a new value, I could go ahead and do that. So say, for example, instead of the radius 0.98, I want the radius to be this value divided by 100. So I could go ahead and write B2_P1 divided by 100. And if I go ahead and update this, it'll automatically be reflected. Now that value is very small, but what I'm trying to highlight is that you can create mathematical correlations between the parameters in your block recording, just like you would be able to do in a normal Python script, in order to get some more relations, some more constraints that may be required for your final design. So I really like block recording because it gives you a lot of functionality. One thing to note about block recording, though, is that this is not simultaneously compatible with setting up parameters in the conventional sense that show up under groups over here. So say, for example, I try to do it manually, right? So I will be able to see the parameter over here, and I can go ahead and make this another parameter, but they will not show up over here. Now, if I were to go ahead and quit block recording, right, then maybe I am able to, create a parameter. So I think somebody was asking how to, choose the ruler dimension for setting parameters. You select a surface, and while that surface is still selected, you click on this guy over here, and then you select a reference location from where, you are measuring that distance. Let me select this guy as the measurement location, and then I can set this as a parameter. So now you will be able to see this manually created parameter under groups, but this is not compatible with blocks. Meaning if I were to turn on blocks right now, and then come and change the value, it wouldn't allow me to, have this value and this guy at the same time. Why is it not giving me an error? It will give you an error. I think right now the block recording is not really turned on because you don't have anything over here, but it is not compatible with parameters over here. You should be able to set up the parameters over here. Okay, now we've talked about SpaceClaim. Let us move to Discovery because I want to highlight some differences, minor differences between SpaceClaim and Discovery for that same process. So I told you how to use Discovery instead of SpaceClaim for the default geometry import by going to Tools and Options and selecting a different preference. But for the sake of this example, what I will do is I will directly go ahead and launch Discovery from my inventor. So if you go to the Ansys 2021 R2 tab, you will notice that there's Workbench and then there's also standalone Discovery. A lot of customers don't own Workbench, but they do own Discovery. So for those people, you can directly just select this option over here. And what it's going to do is it's going to launch 2021 R2 Discovery. And we will be able to import this geometry and track all the steps just like in SpaceClaim. So just give it 1 second. Okay. So this geometry was automatically imported within the Discovery interface. And you will notice that like the block recording already automatically showed up. Similarly, over here, history tracking automatically shows up when you try to connect your active CAD to Discovery. History tracking is very similar to block recording. There are some minor differences between, the GUI interface and functionality. But for the purpose of importing geometry, tracking parameters, seeing how they are updated, history tracking does the same thing as block recording. So for example, here again, if you wanted to go ahead and add these parameters, you could go ahead and do that. And then you could change the value just like you would in block recording to see what sort of modification is caused. So here also you see the same effect. And if we go back to Inventor, you will see that again, it is automatically extended because we changed it from 2 to 3. Okay, so there is no difference as such. Similarly, if I go to Inventor and if I change the value of a dimension over here, I could come back to Discovery, again, right click on it, do update from source CAD. And it will automatically, update it over here, as you can see. Now, one thing to keep in mind about Discovery is that while history tracking is on, you can only work in the model stage. You cannot work in the explore stage. If you try to go to the explore stage, it will give you an error because the history tracking is just for the geometry prep portion. It's not for tracking the steps of how you set up your simulation, right? So this is just for the pre-processing part. If you wanted to go to explore stage, say, for example, you've already made your modifications, nothing further needs to be changed. You can simply go ahead and stop history tracking by clicking on this button over here. And now you should be able to go to your explore stage and set up the physics as you deem fit. Okay. So that was all that I wanted to cover for today's AVA session. Just as a summary, we saw that both SpaceClaim and Discovery can be used for direct modeling and parametric modeling, depending on which functionality is more convenient and efficient for you. So you have the best of both worlds with SpaceClaim and Discovery. We also saw how block recording in SpaceClaim and history tracking in Discovery can automate your CAD cleanup process, how your intermediate steps can be recorded, and how it can be updated by simply just changing the values in the parameter box. And we also saw how to import and update geometric parameters from your native CAD platform inside Ansys. So I used Autodesk as an example today, but you could set up parameters in your native CAD tool, use the prefix ANS and DS and import them within Workbench, and then maintain that connectivity while you perform the steps for geometry cleanup. And we also saw that some of the parameters that were imported, they maintain the link between your native CAD design and your SpaceClaim design. This bidirectionality is limited. So any modifications that you make inside SpaceClaim itself will not be carried over to your native CAD platform. So that is all that I had for you guys today. Hopefully the session was beneficial. Our next session is going to be in January. It's going to be hosted by structure simulation lead Pedro Chu, and it'll be a session that covers contact analysis in Ansys. And the date is not decided yet because we are looking to change the structure of our virtual academy session somewhat. But stay tuned because a lot of exciting things are being planned, and we hopefully are going to have a lot of interesting sessions for you guys in the near future. Another shout out to Ethan Rabonowitz at Ansys Inc., who has helped me a lot with questions related to SpaceClaim and Discovery. So thank you, Ethan. If you guys have any questions, please feel free to leave them in the chat box. Parametric link to HFSS. I'm not exactly sure if I understand the question. So are you asking about the parametric link to HFSS directly from your native CAD platform? Okay, so I'm not an HFSS guy. I'm a CFD engineer, so I don't use HFSS that often, but that is definitely something that I can check up on and let you know about what sort of connectivity can we maintain between native CAD platforms and HFSS. I believe that if you were using SpaceClaim in any part of your engineering workflow, then SpaceClaim could be the intermediate between your native CAD platform and HFSS. But then again, I'll double check and I'll let you know, Mike, for sure. I think those are all the questions. I don't see any other questions, but yeah, hopefully you guys found this interesting and helpful, and I will see you guys later on in another AVA. You guys have a good day. Thank you.